In this video, we are going to see 4 examples of how to factor when you have a 4-term polynomial. So the technique that you normally will use if you're trying to factor 4 terms is factor by grouping. So let me show you what I mean. So the first thing you want to do when you're factoring, so don't forget, you always look for a GCF. So you should look for a greatest common factor among all 4 terms, and if you have one, you would take it out first. So x squared, negative 4x, plus 6x, and minus 24, they don't all have something in common, so there's no GCF to factor out. But if you have 4 terms, you can try to group them in pairs and factor out something that's in common in each pair. So for the first pair, if I'm only looking at x squared minus 4x, they both have an x in common. So I'm going to try to factor out an x. So remember, when you're factoring out a common factor, you write it down, and then you write what's left over when you factor that out. So what's in red is what I factor out, and I guess I'll do blue for what's left. So x squared divided by x, that would just be x. X's cancel, so minus 4. Bring down the sign in the middle, and then let's look at the next pair. So 6x and 24. Those both are divisible by 6, so they have 6 in common. So I'm going to try to factor out a 6. Well, the 6's will cancel and leave me x. Negative 24 divided by 6 is negative 4. Look at what I have in blue. Do you see the leftovers in both cases are the same? That will always happen if it's factorable by grouping. So if you have a 4-term polynomial and it is factorable by grouping, you will always get the same leftovers in parentheses. That's a sign that you can continue to factor. So now you have the x minus 4 in common. So what's in blue makes up one factor, and then what's in red combines together to make up the other factor. And what's really happening here is now you have 2 things. You have this and you have this. And they both have x minus 4 in common. So you're writing down the common factor. Okay, so we're writing down the common factor, which is x minus 4, and then you're dividing that out to see what's left. And so what that leaves is the x and the plus 6 in red. So just remember that whatever is matching gives you one factor, and the leftovers give you the other factor. And this is factored completely. So if you FOILed this out, if you multiplied it out, you would get right back to where you started. So those 2 things are equivalent. Let's look at number 2. Number 2, we have 4 terms. Is there a common factor among all 4 terms? No, there's not. So I'm going to try factor by grouping. So the first 2, I have a 3y squared and a 6y. It looks like they both could be divided by 3. And they both have a y. So 3y is the common factor. When I divide out a 3y, I'm going to have y plus 2 left. 6 divided by 3 is 2, and the y's cancel out. Notice that this time I have a negative here. You always want to bring that sign down and divide it out. Let's look and see what I have in common here. I have a y and a 2. There is nothing in common. In that case, you're just going to divide by 1. And this time it's going to be a negative 1 because that negative sign was in the middle. So we're going to divide by a negative 1. Negative y divided by negative 1. And if you want to put the 1 here, that's perfectly fine. Let me make it so it's not touching. There we go. All right, so negative y divided by negative 1 is y. And then negative 2 divided by negative 1 is plus 2. Notice that what's in blue is the same. So y plus 2 is the same. That's one factor. And then your leftovers, the 3y minus 1, is your other factor. And so this is fully factored for number 2. If it's saying factor completely and you don't get the same thing in parentheses, then you probably made a mistake. Otherwise, it's not factorable. Okay, number 3. We have 4 terms, so that's when we know, oh, I need to try factor by grouping. I look for a greatest common factor among all 4 terms. All the terms don't have anything in common. So I'm going to start with the factor by grouping. These two both have z's, and in fact, they both have at least a z squared in common. So I'm going to factor out z squared. And when I do that, I'm going to have z minus 4 left, right? And the z, remember, I'm subtracting the exponents. So the 3 minus the 2 gives me the 1z left, right? Okay, so now I'm going to bring down the negative. So I'm going to be dividing by a negative. And then a 5z and a 20, they can both be divided by 5. So I'm going to be factoring out a negative 5. So that'll leave me z, right? The negatives and the 5s cancel out. 20 divided by negative 5 is negative 4. Notice the z minus 4s in blue are the same. So that's one factor. And then what's on the outside in red makes up your other factor. And that's fully factored. Now, whenever you have a factor like what we have in red here, it's z squared minus 5. If you still have an exponent on your variable, you should be thinking, can I factor that more? So if you have learned about difference of squares, this is possibly factored if the 5 was a perfect square. So if it was like z squared minus 9, you could factor that into z minus 3, z plus 3. So it would be factorable again. But that's not the case here because 5 is not a perfect square. So that's as far as you can take that one. But be suspicious. If after you factor, you still have a square, you might want to just check to see if you could factor that again. Number 4, we have 4 terms, so that should indicate factor by grouping. The first thing we always want to check is there a common factor among all 4 terms? Well, this time I have numbers that look like they could have something in common. So 16 is divisible by 4, so is 40, so is 24, and so is 60. They don't all have an m because the 60 is a constant, so that's out. But they look like they're all divisible by 4. So that means that's a greatest common factor, and I need to factor that out before I go further. So 16 divided by 4 is 4, so that'll give me 4m cubed. Negative 40 divided by 4 is negative 10, so negative 10m squared. 24 divided by 4 is 6, so 6m. And negative 60 divided by 4 is negative 15. All right, so now the next step is looking at what's in parentheses to see if I have another common factor among all 4 terms. And 2 looked good until I got to the 15. 15 is not divisible by 2. And 4 won't work either, so that's it. I did get the greatest common factor of 4 out. If you don't remember to do that in the beginning, you more than likely are going to miss some points because you didn't factor completely, which is what the directions said. So make sure you get in the habit of looking for that. So now what I want to do is I want to look at just what's in the parentheses and try to factor that. So what I like to do is now I'm going to kind of highlight this 4, remind myself that I have to bring it down, but I'm going to ignore it for now. I'm just going to look at what's left in parentheses because I want to see if I can factor it more. Since there are 4 terms, I'm going to try factor by grouping. So let's see if anything is in common with the first pair. They're both divisible by 2. They both have an m, and in fact, they both have m squared. So I can factor out 2m squared, and if I divide that out, I will get 2 and then m cubed over m squared, that just leaves m. 10 divided by 2 is 5, and then the m squares cancel. So 2m minus 5. Bring down the plus. It looks like both 6 and 15 are divisible by 3. They don't both have an m, so just 3. Now, before you actually divide, think about what you want to get. If this is factorable, I should get 2m minus 5 in parentheses because that's what I got in the first set of parentheses. And they should match if it's factorable. So 6 divided by 3 is 2, and I have the m. And then negative 15 divided by 3 is negative 5. So I did get what I wanted, so that's great. So now I have 2m minus 5 is the common factor. That's what's in blue. And then what's in red, the leftovers, make up my other factor. And now the last thing I have to remember is to bring down that 4. That was the greatest common factor from the beginning. And I just put it in the front. I should be suspicious because I have an m squared in the last factor, but that is actually not factorable any further. So that is my answer right there.